Hello students, in the previous videos we have discussed about various methods of preparation of ammonia. Now in this video we are going to see the industrial process or the manufacture of ammonia, as ammonia is required in large quantities. How we can manufacture in the industry, that is what we are going to see today. Keep watching. Manufacture of ammonia by the industrial process called Haber's process. The process is known as Haber's process. Now it is named after the scientist who designed this. His name is Fritz Haber. So he has designed this. The purpose of the Haber's process is to manufacture ammonia. Underline and note this word manufacture. It is important to write manufacture ammonia. What do you mean by manufacture? It means that to prepare in large quantities at cheap rates, large quantities and cheap rates. And why do we prepare? For commercial purpose, not to study properties, to sell and get profit. That's why it is in large quantities. Now to sell and make profit. Ammonia in a country like India, where a lot of agriculture activities are going on, we need large amount of ammonia, because ammonia helps us to prepare fertilizers, nitrogenous fertilizers. So it is required in large quantities in a country like India, where huge population is there and large amount of food products are required. The raw material should be cheap and readily available. Why? Then only we can make profit. When it is cheap, then we can sell it at cheap. So the agricultural products will also be cheap, the crops will be cheap. So the reason, therefore, ammonia has to be manufactured at cheap rates. That is a necessity of our nation. Now let us see how we can do that. What are the reactants in the Haber's process? The Haber's process, the reactants are hydrogen and nitrogen. Now how to get hydrogen at cheap rates? We get it from a process called Bosch process. In the Bosch process, hydrogen is obtained from water gas. Water gas is a mixture of carbon monoxide and hydrogen. So we know that hydrogen is obtained there. So coke or charcoal, white hot state, steam is passed over it. So what you get is a mixture of carbon monoxide plus hydrogen. This is what is called water gas. Yes, now water gas is further mixed with steam. This is water gas, again steam is passed over it. So what you get is CO2 plus 2H2. Now this hydrogen is separated and used in large quantity, so it is cheaper. Water is cheap and charcoal, wood charcoal is all cheap. So you get hydrogen at cheap rates. Then nitrogen is obtained from fractional distillation. Fractional distillation of liquid air. What they do is, first they remove the dust particles and carbon dioxide and moisture from the air. So dust particles by electrostatic precipitator, moisture by using a fused calcium chloride, and then they remove carbon dioxide by using caustic potash or KOH to remove carbon dioxide. The remaining part of the air contains only oxygen and nitrogen. So now this is liquefied, so you get liquid air. Okay, this part is liquefied. Now on the liquid air, on evaporation, what you get is oxygen vapor goes out and nitrogen in the form of liquid. So you get O2 and N2 separately here. So this nitrogen is very cheap because air is cheap, air is free. So as you get it from air. So we have both the reactants or raw materials for the industry, hydrogen and nitrogen obtained by cheap sources. So the product will be cheap. Now the next thing is the catalyst. The catalyst for the manufacture of ammonia in Haber's process is finely divided iron. Finely divided iron. Finely divided means very fine powder. Very fine powder. Iron in the form of very fine powder. Okay, powder will increase surface area, we have already seen. Then there is a promoter required. The catalyst, what is a promoter? A substance that enhances the ability of catalyst, enhances the ability of catalyst. So the catalyst alone is not sufficient, we need a promoter. Now the promoter here in this process is molybdenum, is a metal, molybdenum, Mo is the symbol. So we use finely divided iron along with the molybdenum. So this together will be catalyzing the reaction. So it will increase the efficiency. Catalyst is a substance that alters the rate of reaction. Here it is a positive catalyst. It increases the ability of the catalyst, right? Now the whole reason why do we need all that? Because nitrogen is inert in nature. Nitrogen molecule we know is there is a triple covalent bond between two nitrogen atoms, or we can write N triple bond N. So the bond, breaking of this bond is difficult. The triple covalent bond, presence of triple covalent bond makes nitrogen inert. Nitrogen is made inert because of the presence of triple covalent. It does not break easily. So we need to give extreme conditions. Not only this is enough, there are more conditions. Now the reactants must be pure, hydrogen and nitrogen, because impurities, if any impurity like carbon monoxide, carbon dioxide or hydrogen sulfide where, it will poison the catalyst. What is poisoning the catalyst? It will deactivate or it will reduce the efficiency of the catalyst. Reduce the efficiency of the catalyst. So what happens is the yield will be less, the product obtained will be less in quantity too, and it will slow down the reaction. So to avoid this, what we have is to have the reactants pure. Now the temperature for the reaction is 450 degrees Celsius to 500 degrees Celsius. This is an optimum temperature range. Below this and above this is not safe. You get better yield when the temperature is between 450 and 500 degrees Celsius. Below 450 degrees Celsius, what happens is the reaction is negligible, and above 500 it is reversible. Now optimum pressure of 200 atmospheres to 900 atmosphere is chosen. Here again a limit, a lower limit and an upper limit. Below 200 atmospheres, mostly the reaction is negligible, and about 900 atmospheres is not safe. It's a very high pressure. So the reaction is nitrogen reacting with hydrogen. It's a reversible reaction producing ammonia, NH3, 2 NH3 and 3 H2. So this is how it is balanced, and it is exothermic also. Heat is produced during the reaction. Now all the conditions apply here. Ferric Fe/MO, finely divided ammonia and ion, and molybdenum as catalyst and promoter. Temperature 450 to 500 degrees Celsius and pressure 200 to 900 atmospheres. So this setup is possible in the industry. So it is possible to conduct. Now you can see the industrial setup, how things are happening in the industry. You see this hydrogen gas is taken, and we have nitrogen gas. Both the gases are coming together, 1:3 ratio, they are mixed together. It is going into the chamber called catalytic chamber. This is the catalytic chamber. Catalytic chamber, where the temperature is 450 to 500 degree Celsius. Pressure is 200 to 900 atmospheres, and the finely divided ion catalyst along with molybdenum promoter is kept there. So it will react and the product comes out. That is the reacted. The product is ammonia. Ammonia comes here, which will be separated out, and any unreacted nitrogen and hydrogen present will be sent back to the compressor, and it will be sent to the catalytic chamber. Okay. So these are the steps here. Now here you have the apparatus setup, the industrial setup here, where high pressure equipments are used there, right? Now let us understand this. The product ammonia formed here may contain some nitrogen and hydrogen which are unreacted. How to separate them? One is by liquefaction. On cooling under pressure. Cooling under pressure. What happens? Ammonia liquefies. It changes to liquid. Okay. Liquefies. While nitrogen and hydrogen, they remain as gases. So they can be recycled. Okay. Same way, if you pass through water, dissolution in water, what happens? Ammonia, when dissolved in water, forms ammonium hydroxide, NH4OH, which is alkali. So this is another form we can store. And the nitrogen and hydrogen, they do not dissolve. so they can be separated. So this is how we get finally ammonia or ammonium hydroxide. Either of that can be obtained from the Haber's process. So students, I think you understood how the Haber's process is employed in the manufacture of ammonia. The final product here is ammonia in the liquid form or ammonium hydroxide in the aqueous form. Either of that can be prepared, and both are useful in the industry. So you have queries, you can write as comments and subscribe and like the channel. Thank you.